Alright, we're back and we're still talking about the chain rule, and we're going to work through several examples. And here's the first one. Y equals the square root of x squared plus 1. And we have to find the derivative of y with respect to x. Now, we could try the definition of the derivative. We could just try the limit as delta x approaches 0 of the square root of x plus delta x squared plus 1 minus the square root of x squared plus 1, all that over delta x, and then use a conjugate up here to try to simplify all of this and take the limit. We could try that, but we won't. The chain rule is much faster and much more accurate because it involves a lot fewer computations and fewer steps, so it's less error prone, and it's just a very, very elegant approach. So let's tackle this one with the chain rule. I'm going to say y is equal to u to the power of 1/2. That's my original function. And this is a good way to state it, and that's a correct way to state it if u is x squared plus 1. So u is my inner function. And now let's differentiate each of these. Let's find dy du, which we can find with the power rule. That's going to be 1/2 u to the negative 1/2. And let's find du dx, which is simply 2x. And the derivative that I'm looking for, dy dx, has to be dy du times du dx. So let's just write that. Dy du is 1/2 u to the negative 1/2, and I'll write that as 1 over 2 u to the 1/2 times my du dx, which is right here. So that's times 2x. And these x's cancel out. I'm sorry, these 2's cancel out. And I'm left with x, that x right there in the numerator, and the square root of u in the denominator. And u is this. So in the denominator here I have the square root of x squared plus 1, and I'm done. That's the derivative of y with respect to x. Okay, here's example 2. Y is equal to sine of 3x. Find dy dx. Okay, let's rewrite y as the sine of u. And that's a good way to write y, as long as u is equal to 3x. So let's find the derivative of each of these. Dy du is equal to the cosine of u. We saw earlier that the derivative of the sine function is the cosine function. And du dx is simply 3. So the derivative that I'm looking for, dy dx, again, that has to be dy du times du dx. And dy du is the cosine of u, and du dx is simply 3. So it's the cosine of u times 3. And we typically write that with the coefficient out front, so I'll write 3 cosine of u, but instead of u, let's substitute in this 3x. So it's 3 cosine 3x, and that's my answer. Now it's really helpful and most useful to think about the chain rule as a procedure for finding the derivative of composite functions. And you can state the procedure like this. The derivative of the outer function with respect to the inner times the derivative of the inner function. And we will start to look at the chain rule and think of it this way as we solve the problems. The derivative of the outer function with respect to the inner times the derivative of the inner function. Now here's example 3. Y equals x to the 4th plus x cubed. And we're told to find the derivative of y with respect to x. So let's rewrite the function as y equals u cubed. That's our outer function, the cubing, and this u here is our inner function. And then That's going to be the case if u is x to the fourth plus x. So u is the inner function. And when we do dy du, we're treating this x to the fourth plus x, this thing on the inside, is just this inner thing, and we're doing the derivative of the outer with respect to that. That's the derivative of y with respect to u. So that's the derivative of the outer with respect to the inner. In this case, it's 3u squared. And then this is the derivative of the inner, the du dx. I simply differentiate the inner function, and in this case it's 4x cubed plus 1. And so when we do this little procedure, dy dx is equal to dy du times du dx, this is the derivative of the outer with respect to the inner, and this is the derivative of the inner. So think of that as a procedure. The derivative of the outer with respect to the inner times the derivative of the inner. So this is 3u squared times 4x cubed plus 1, and then we substitute back in for u. So this is 3x to the fourth plus x squared times 4x cubed plus 1. Now I'll take you through the solution here where you go from here to here in one step in your head by thinking of it as a procedure. And here we go. The derivative of the outer with respect to the inner. So my derivative is going to be 3 times the inner thing squared. So my outer function is this power function, this thing raised to a power. So I do the derivative of that with the power rule. 3 times that thing squared times the derivative of the inner function. And the derivative of the inner function, you can just look at it and see it will be 4x cubed plus 1. So that's it. The derivative of the outer with respect to the inner times the derivative of the inner. That's the chain rule. Let's do another one and think it through in the same fashion. Example 4 is y equals sine squared x. And it might be easier if you think of it like this, or write it like this. Y is equal to the sine of x squared. Written this way, you can see that the squared is clearly the outer function, and the inner function is sine x. So what's the derivative here? Well, y primed is the derivative of the outer with respect to the inner. So just think of this, sine x as one thing. So y is that thing squared. So just apply the power rule, and you get 2 times that thing to the first. And you don't even need to write the 1. So that's the derivative of the outer with respect to the inner, and then times the derivative of the inner. The inner function is sine x, and the derivative of that is cosine x. So we get 2 sine x cosine x. And we'll continue with some more examples in the next video.